to talk about, we've already talked about series, and we've talked a little bit about summation notation already. We did them a little bit with we did arithmetic sequences and series. So just a reminder, a series is a sequence with plus signs between the numbers instead of commas. So a sequence will give you a bunch of numbers with commas between them. If it's a series, then there's going to be addition or subtraction signs between them, telling us to either add the numbers or subtract the numbers. We use the capital letter S to represent a sum, and the subscripts then tell us how many numbers we're adding together. So down here we have the partial sums, S sub 1, S sub 2, S sub 3, and S sub 4. Just tell us how many specific numbers we're going to add together. And then we talked about this summation notation, the Greek letter sigma. And this means that with this formula here, so it tells us the k equals is the first number we're going to start with, so we're going to plug that number in first, and then we'll use all the numbers up to the last value, which is on top of the sigma. Now, we're not doing example 1, okay, so don't write that down. And then we have the rule for that we're going to work with is what goes to the side of it then. Okay? We're going to decide that we're not going to write them in take the series and put it in summation notation. All right. I think you guys had enough difficulties yesterday with the just writing those, right? Okay. Even though nobody asked for any of them. So we're gonna bypass them and go on. I thought about doing them still, but we're not gonna. All right. So we're gonna go to example 2. So we're just gonna work with summation notation today then. Right? We've done, in your homework today, you're going to be doing some work from the arithmetic sequences in series 2, so you'll work with them more of that stuff then. So it says evaluate a series. It's expand each series and then evaluate it. So when it says to expand, that means we're going to put all the numbers in, show the addition that we're going to do, and then we're going to add them up. It's very simple. And then when we're all done today, I'm going to show you how you can, well, at some point in time, I'm going to show you how you can use your calculator to find these answers. But even though your calculator will help you, when it says to expand, I'm going to expect that you are writing it all out. Okay? So when it says expand, it just means I'm going to take this and I'm going to put in 2 for k, the very first number, because I'm starting here because it says k equals 2, so 2 goes in there first. And then I put in 3, and then I put in 4, and then the last number is 5. So that's the expansion right there. Now, as part of the expansion, that means that I have to simplify it before I can actually add them together. So I need to raise 3 to all of these powers. So 1 over 9 plus 1 over 27 plus 1 over 81 plus 1 over 243. And then I need to find the sum. So what do those fractions all add up to? And I think it's 40 over 243, but you might have to correct me if I'm wrong. It's been a while. Why not? This is actually very easy, okay? And I'll tell you why it's very easy. Okay? Because to get from 9 to 243, I just need to multiply by 81. No, it's not 81. It's 27, right? Thank you. So this is 27 over 243. Oops. 243. All right. This is 9 over 243. And this is 3 over 243. And 1 over 243. Right. And if I add them up, I get 40. So that one actually wasn't that bad because of the denominators all have something in common, so it actually makes it easy to get the common denominator then. See, that wasn't so bad, especially considering I did it for you.
Yeah.
Okay. So when it says to expand them, all we are is putting in the numbers starting with the one in the bottom all the way up to the one on the top, and then adding them together. Okay. Letter B. We're going to find the sum as k goes from 1 to 6 of k squared minus 10. So that's how we read this. The sum as k goes from 1 to 6 for k squared minus 10. So we start with 1 and go all the way to 6 and plug those numbers in for k. So we have 1 squared minus 10. That quantity plus 2 squared minus 10. And then 3 squared minus 10. And as my writing is going to get smaller as we go here, plus 4 squared minus 10, 5 squared minus 10, and 6 squared minus 10. So we put 1 in for k, 2 in for k, 3 in for k, 4 in for k, 5 in for k, and 6 in for k. Now we need to simplify each one of them and add them up. So we get negative 9 plus negative 6 plus negative 1 plus 6 plus 15 plus 26. And when I have things like this I'm adding together, I like to match them up as far as like the negative ones and the positive ones. And so it actually makes it a little bit easier for adding them. Because like I have a negative 6 and a positive 6. When I put them together, I get 0. All right, so boom, those are gone. All right, negative 9, negative 1 is 10. Plus 15 is 5. Plus 26 is 31. I mean, you have your own way of doing it, and that's fine. Okay, so that's not too bad, right? Okay, so there's those answers, and so the expansions really, it's not that difficult, it just takes a little bit of time to do it. If you want to be able to do them with your calculator, then if you have a TI-84, okay, the TI-83, I think it'll do it. I just have to find it. So if we go to math and then over to number, all right, nope, it's not there. Where is it? Right there? Oh, here it is, right here. Summation, 0. Okay, go to math and then 0. All right, now if you got the TI-84, it sets it up for you just like it is on the screen. If you have a TI-83, all right, go down. No, you don't have it then, do you? All right, if you have a TI-83, then you don't have it. Now, for the variable here, it doesn't matter what you do. All right, poor Brittany, but she can use one of the other calculators when she's in here. So what letter you use doesn't matter as long as you use the same letter. Okay, so we'll just use X. That's always easiest to do. So if we do the, well, let's do B. So we're going to go from 1 to 5, and then put in negative 5 times 2 to the power of x minus 1. And we get negative 155. So the calculator, you can put it right in your calculator exactly as it is in the book, and it'll give you the answer. Right? So the only thing you can use that for is to verify that your answer is correct. You can't use it to expand. All right? So when it says expand, you still have to do the expansion. All right? Okay. All right, there are some formulas to help us with specific summation problems. Now, the thing is that these were all created before the wonderfulness of calculators nowadays and computers. And so they gave you formulas that you could use to find them if you just had a constant here, if you just have a linear value of just k here, or if you have a quadratic, it's just k squared. Right? So those don't.
Like, who just in there just starts thinking about this? Like,
some great mathematicians.
I don't know.
That was back before TVs and video games and all that stuff, where they, if they were a mathematician, they spent time trying to figure things out. And they came up with these formulas by actually going through and playing around with the numbers and seeing what would happen. And you know, yeah, I love those guys. They did all the work for us. So now we can sit around and play our video games, watch TV, and just use their formulas that they created for us. So there's not a lot of new stuff that's created mathematically, except for the stuff that's used now for technology. But most of the mathematics was those guys in the old days sitting around and figuring things out. Okay. So, two methods to evaluate series. One, we can write them out, expand them and evaluate. Or number two, we can use the formulas. So here it says the sum as k goes from 4 to 10 of 6. So this is a constant series because this here is just a constant, the number 6. So we need term numbers 4, 5, 6, 7, 8, 9, and 10 are all going to be just 6. Okay? Because that's what that means, right? The fourth term is 6. The fifth term is 6. The sixth term is 6. The seventh term is 6. So how many times am I going to add 6 together? And the answer is 7 times. So we'll take 7 times 6 and get 42. All right, and the big thing here is you got to remember you got to count the 4. If you do 10 minus 4, you get 6, but you're really not counting the 4 when you do that. So it's actually 7. Right? Or we could expand the series, which means we're just going to write out 6 plus 6 plus 6 7 times and add them up and we get 42. So a constant series is pretty easy. However many numbers you're going to add up, you multiply it by that number. Way easier just to do that than to take the time and plug it into my calculator. The fourth term, the fifth term, 6th, 7th, 8th, 9th, and 10th. There's 7 numbers there, okay? All right. Okay.
I got it now.
Okay. All right. So that's when we have a constant. All right. And they have a little caution over here, all right, to specify that if we go from 5 to 10, there are 6 terms there, not 5 of them. All right. When we have just a constant, or not a constant, but just a linear k. When it's linear, the formula says we're going to do, this is when it starts at 1, okay, and goes to n. So we're going to do n times n plus 1 divided by 2. So in this case then, we'll do 8 times 8 plus 1 divided by 2. So 8 times 9, 72 divided by 2 is 36. Using the formula. Because here's the formula for if it's a linear, just k, n times n plus 1 divided by 2. So 8 times 9 divided by 2. Or you could write out the numbers 1 through 8, add them up, and get 36. This was one of the reasons why we did that one handout first. Okay, is that I wanted you to actually explore doing these things before we actually got into the formulas, so that you would understand that, hey, I can just add these up. Okay, I don't have to use specific formulas. Okay. And when it's a quadratic series, the formula for that is n times n plus 1. Let me take a picture of that, move it down. Great. So with a quadratic series, we have n, which is 12, times n plus 1, which is 13, times 2n plus 1. So 2 times 12 is 24, plus 1 is 25. And this is divided by 6. Right, so let's see, 25 times 13 is 425, times 2 should be 850. Right? Oh yeah, 650, sorry. My multiplication's off today.
Alright. I couldn't do 6.
You can do 12 divided by 6?
2.
Yeah, all right, there you go. Okay, or we could expand it, write them all out, and add them up also. Okay, or now you could even use the calculator with plugging it in. Now also, if you've got the 84, you can go alpha window, and summation is the second one there. All right, we'll go alpha window. So we could plug in x, goes from 1 to 12, and x squared, and get 650. Okay. So any of those methods will work for you. Okay. All right, one last problem we're going to do then. Story problem. Now, I always think of, when I look at these kind of problems, I always think it's much easier to do these without using formulas than with formulas. Much easier to write things out, make a table, and work with my table. So Sam is laying out patio stones in a triangular pattern. The first row has 2 stones, and each row has 2 additional stones as shown below. How many complete rows can he make with a box of 144 stones? So this is actually just like that problem from the quiz. Okay? So the best thing is that you want to keep track of 2 things, or 3 things, okay? The row number, the number of stones in a row, and the total number of stones used, because we only have 144 stones to use, so we need to make sure that we don't go more than that. So we have row 1, we have 2 stones, which gives me a total of 2. Okay, so I have the row number, row quantity, QTY, and the total. right, so I'm going to keep track of 3 numbers. All right? So row 2, there are now 4 stones, which gives me a total of 6. Right? We've used 6 stones now. Row 3 is 6 stones. Now I have 12. And so I just have to, by making the table and keeping track, it makes things easier for me to make sure I don't go over. Row 4 is 8. Now I have 20. And then I'll just keep making my table until I get to the point I want to be at. So row 6, 12, 42. So we can do 11 rows of stones. Because of row 12 would be 24, which would give me 156, which is greater than the number of stones I have. So we would have 11 rows of stones then. With the 11th row holding 22, and then I'm using 132 total stones. Now you could write a summation, do summation notation and write the formula and use that if you wanted to also. I think, and that works. It's just the problem with that is you're still guessing and checking because you still got to add another row and add another row until you get to that where your sum's too much. So I think it's easier just to make a table and work from there.